In this video we will see how the sinusoidal EMF is generated in an alternator. That is sinusoidal EMF. Sinusoidal EMF in generator. In order to explain this process, now I am considering a elementary single conductor two-pole machine. That means this generator consists of a single conductor and two poles. Now let us consider the following diagram. This is the rotor, salient pole rotor, two poles. That means one north pole and one south pole. This is north pole, this is south pole. And another, there will be a stator like this. This was the stator. Okay. And from the north pole, the lines of forces will be out of it like this. And at the south pole, the lines of force are entering into it like this. Now let us consider a conductor was placed at here. This was the conductor, and let us select a reference point. This was the reference point. Let us say it is at 0 degrees. It was 90 degrees. It was 180 degrees and 270 degrees and again 360 degrees. This is nothing but space angle. Space angle. This is nothing but space angle. Space angle. Okay. Now let us see how the flux is distributed in the air gap over the space angle. Let us consider this. This is the space axis in the sense theta, and this was the flux density B. Now at 0 degrees, this was 0, this was 90, this was 180, this was 270, and this was 360. Now so the EMF will be 0. Okay. Now let us consider by some means theta. By some means this rotor is rotated at some 90 degrees. Now the position of the rotor will be like this. This will be north pole, this will be south pole, and the position of the conductor is like this. This is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and again 360 degrees. And now how will be the flux density B? At 0 degrees there were no flux increases, it will be 0, and at 90 degrees maximum flux is there, so maximum flux density. At 180 no flux increases, it will be 0. At 270 negative flux increases, and 360 will be like this. Now what about the generation of the EMF? The EMF generation will be maximum at 90 degrees because there is maximum flux density in the conductor. So how this is happening is E equal to BVL, BVL sin theta. That means that E is depends upon B, flux density. If this is more, this will be more. If this is less, this will be less. Okay. In this way, these two are related. Okay. Again, this it will be traced like this at 90 degrees. That means this flux density graph is moving with synchronous speed ns with respect to time. With respect to time is moving with respect to time. Now this rotor is moved further 90 degrees, then the position of the rotor will be like this. So what's there? Now this will be north pole and this will be south pole. Okay, this will be north pole and this will be the south pole. That means the connector was placed till here only. This 0, 90, 180, 270 and 360 degrees. Now this was theta. And what about the flux density at 0? It is moving into the plane. That means negative maximum. And at 90 there is no flux linkages, 0. And at 180 it was moving out of the plane. That means flux density is maximum. And here it will be 0, 270, and again at 360 it will be maximum. Now what are the flux cutting this connector? Is 0. That means at 180 degrees the EMF induced will be 0, and this process is continued like this. That means this flux is moving then synchronous speed ns. That means, see, as the rotor is moving in space, the flux is also moving at space. At what velocity the flux is moving means how the rotor moves at synchronous speed, because it is a synchronous generator. Similarly, in the same manner, the flux is also moving like this, and the generation of the EMF depends upon the position of the rotor. That means the position of the rotor flux. Okay, thank you.